Before I get started, I just wanted to tell a little experience that I have couple of actually a few months before. So I was working on one of my Go project, and they were like really tight deadlines. And as you know that when there's tight deadline, you don't want anything to be changed, especially in terms of your build. So once you have done with your functionality, you want your build to go on and check it in. So actually, I was working on my build and I wanted to get this fix in, and then suddenly I get an error saying that there is an invalid pseudo version. And this project is not the first time I'm using. I have been using these dependencies from a very long time. So I thought maybe there's something changed in the version control system, that version has been removed or something. Let me check what is there, whether my proxy has been set up or not. So I check in my Go environment, I check my GoProxy, and it was not set up. So I set it up to GoCenter, and I knew that it was, I have already processed this module in my proxy, so it would be there. So I did the build again. So the build again failed on me, saying that it cannot find this module in GoSomeDB. So at that time, I mean, I was not aware that there were any changes in Go 113 or something, but I realized that actually I upgraded to Go 113 the previous day, and that's why all those things have come up. So I mean, since I didn't have much time to resolve all those things or look for the solution, I reverted to the default. So from all those experiences, these my today's talk is going to be. So yep, let's get started. Um, I mean, as I've already introduced, I'm a software engineer at JFrog, and I'm also a GoCenter developer. So if you have any question, if you're using GoCenter, or if you want to use GoCenter, or you have any questions, you can always reach out to me at Twitter, or I'm also on Go for Slack. And I'm also engaging with the committee to have their module secure. So if you want to get knowledge about it, whether your module is vulnerable or not, you can always reach out to me. So before going further, the exciting thing in this time where we are like all at home and we are a little bit away from getting the swags, going to the meetup. So we are giving one of the 3 JFrog Go for t-shirts. Today here is the barcode. You can scan it, and also you can win one of the 2 Nintendo Switch Lites, which will be in our June sweepstakes. You will get the barcode at the end also. So okay, so by the end of this talk, you will know what is special about pseudo versions. Why do we use pseudo version, and what verification has been put regarding pseudo version in Go 113. How to fix those problems if you have in one of your pseudo versions, and what is there in Go 114 or later releases related to the Go modules. Since we are talking about Go module, what is actually a Go module? Go module is a list of Go packages which are stored in a file tree, which has a go.mod file at the root of its directory. And this is an example of go.mod file that I have taken from one of the module, which is a containers common module. This is not the full go mod file, as it has a lot of dependencies. So I've just cut it down to just fit it in the screen here. So the go.mod file has first it will explain the module path, like module github.com containers common, and then it will have your Go version. And then it will have a required directive. The required directive actually contains all the dependencies that your project is using, along with the versions. So as you can see here, there are different kind of dependencies like toml, storage, runc, and you can also see the specified versions. Now talking about the versions, Go always prefer to have a normal version release, but you can always have a pre-release if there's any situation like that. But you can create the module versions by tagging the version for the release by a version control system. The first three module and the versions are actually the release versions, and they are in the form of semantic version format. You might have already be aware of that. Semantic version format is in the form of x.y.z, where every parameter changes based on the API changes that you have made for the project. So suppose X, the first is called the major version. If you don't have any backward compatible API changes, then you increase that version. Second is the minor version. So if there is any compatible changes for the API, then you increase that version. And last one is the patch version, which is only for bug fixes for the compatible releases. Going to, like, if you don't want to release like actual semantic version, you can always have a pre-release version by appending a hyphen and a string. And a string can be anything. It can, like, it's RC9 here. People usually use like alpha, beta, and all those things. And the last long ones that you see, the weird ones with the very long strings, are actually the pseudo versions. And about those we are going to talk about next, how they are defined. So pseudo version are usually the untagged revisions, as I already told. Why we actually need pseudo versions? Sometimes, like, our project is dependent on some project which has not published any of the same word tags, or you have to develop against a commit which has not been tagged yet. So in those particular scenarios, we tend to use pseudo versions. The format of the pseudo version is, it has three components. The first component is the most recent tagged version in the commit graph before this commit. Followed by is the timestamp, which is the commit time in UTC. And the last part is actually the prefix of commit hash generated by the underlying version control system. So these are the three components, but do keep in mind that we should never be typed this pseudo version by hand manually, because Go command take care of it. If you just pass the commit hash, it actually converts your commit hash to the corresponding pseudo versions. But there are many pseudo versions out there, which are, people usually tend to change the timestamp or something, or maybe the commit part. So that should not happen, because there can be many problems that can happen with that. So if you change anything manually, since pseudo version also participates in minimal version selection, what it means, if you change the version prefix and to anything, then pseudo version might appear to have higher precedence than the versions following it, which has released follow it, and it will pin that particular pseudo version to your module, which will not be correct. The second part is the timestamp, which is a very important part in the order of the pseudo version. So if you change the timestamp, obviously the sorting of the pseudo version gets messed up, and it will again give you the wrong pseudo version that you don't want. So Go team has realized all these problems, and that's why there are stricter rules that have been enforced in Go 113, so that all these parameters should be taken care of. So let's see, before Go 113, what do you see? Before 113, if you do go get on any of the, so before Go 13, if you go get for, suppose, some module with any combination of version prefix and timestamp, what it will do, it will actually resolve it to latest for that commit hash, and it will put it in your Go mod file. So it was super forgiving in that sense, and it will not complain for it. But as you can see, it's showing the same timestamp at you have demanded, but it was actually not correct. But starting from Go 113, if you ask for a pseudo version which is actually not valid, it will give an error saying that this is an invalid pseudo version, and which doesn't actually match the control timestamp. So what are the rules that have been enforced for pseudo versions? So let's take an example of the same GoRod mod file with any of the pseudo version. So the first part is actually the version prefix that the pseudo version should generate from the version major prefix or any of its descendants. The second part is the commit time, which should be the commit time that has been generated by the version control system. The third part is the prefix, that should be the same prefix as it has been generated by Go client or any other or version control system. So these are the three validation that has been enforced on the format of the pseudo version. The fourth validation is incompatible suffix. So you cannot have incompatible suffix for pseudo version if it is not required by the major version, and you can only have it is if it is required by the major version and you don't have go.mod file. And the last but not the least is the checksum server validation. As we know that starting Go 113, GoSumDB has been introduced. So GoSumDB is actually a transparent log of cryptographic hashes of module versions to make them immutable. So whenever you do a go get, so checksum server does the same validation for pseudo version validation, and if it doesn't find it, it's gonna give you 404. The same error that I was talking, in the first part. For a Go checksum server, I mean, Deep is going to talk a lot more in his talk next. So let's see how can we fix these pseudo versions so that you can seamlessly, move to Go 113. So you have to fix two things. You have to fix your direct dependencies, which are in require directive. You have to fix your transitive dependencies. So for the direct dependencies in the required directive, instead of putting the whole pseudo version, which might be correct or not, you might not know what is the correct one. So just put the commit hash part and do go mod tidy or go get. So the go command will automatically resolve it and replace with the correct pseudo version in your mod file. For the transitive dependencies, if there are anything which are using incorrect pseudo version, you can use a replace statement. Replace directive in your go.mod file. So instead of using the whole pseudo version, just use the, as I said before, the commit hash part for the replace, and it will replace it to the correct pseudo version. So how GoCenter as a proxy can help? We, as a community person, we realize this problem that many people might be facing. So we have accommodated some changes related to that, so that because we want to serve the modules irrespective of the version. So if there is any change, we also want to comply with the Go ecosystem. So GoCenter actually changed. So whenever there is a module download request, GoCenter actually changes the .info content with the correct pseudo version and send it for download. So that you will have the correct pseudo version downloaded. So what are the changes before Go 113? So for any users who is using Go 113 or below, so if you try to do go get for any pseudo version which is not valid, so if you see here, the timestamp is actually invalid. So if you're using GoCenter, GoProxy as a GoCenter will automatically resolve it to the correct pseudo version. With that, so if you can see here, the timestamp has been changed, which is the correct one. So the change is completely transparent to the user. For Go 113 and above users, if you try to do a go get for invalid pseudo version, you will get an error. I mean, which actually will redirect you to the correct pseudo version, saying that this particular pseudo version proxy wants you to return. Instead, if you want a proxy to update in your go.mod file and not to give you an error, you just have to change your go command to use only the commit hash part rather than using the whole pseudo version, and it will automatically be put the correct pseudo version in your go.mod file. So that's how that the change that we have made. So now we have gone from Go 112 to Go 113, and we know that Go 114 has released in March, and there are some changes related to the Go module that has come, or I can say new features that that might be useful. So if from Go 114, you can use actually a mod file flag. In that, you can give an just a path to a different mod file. So instead of using go.mod file in your root directory, it will use the mod file which is there in that particular path, and it will completely ignore your go.mod file at root. But do keep in mind that you should have a go.mod file at your root, so that it will define that, okay, this is the root directory. It doesn't have to be, it doesn't have to contain anything. Go get with mod flag, it will not allow you to set now anymore. Before, it either used to ignore it or it used to give error, and ultimately, polluting your go.mod file. So Go team has realized that this particular problem, and they have actually stopped letting us set the mod flag. The go get upgrade to an incompatible major version will not happen automatically unless there is anything specifically required for that major version. This is an exciting one, that now we can see a plain text error message from our module proxies and other HTTP servers until unless they are in UTF-8 format, and they can contain some graphic characters and everything. And finally, now we have a SVN repository support in module mode. And we know that from Go 113, module mode has been enabled by default. So if you have not migrated to Go module yet, you should be doing it. So now Go 115 is going to release actually in August, and that is going to be a comparatively smaller release, which will have major of the changes in terms of tooling than any external changes which can affect user. But you can always go to a site where we have proposals and everything for Go, and there are some changes that have been merged. So finally, I'm going to post my slide on Twitter, and this is again the barcode for the Go for t-shirts. And now I can open up the questions if you guys have anything.
Yep. If you have questions, you can drop them in the chat, or if you raise your hand, I'll be happy to unmute you and you can ask your question out loud. Troy says that he doesn't have a question, but we'll say thank you.
Thank you, Troy.
All right, last call for questions from Vitaly.
So I think everybody understands everything, or everybody understands nothing. There could be one blow. So.
And we can always, if you guys think of any questions, you can always type it in the chat and we can come back to it.
Yeah, and you can always, like, later if you see slide and have some questions, you can always Slack me or Twitter me.
Awesome, thank you, Vitaly. Well, Dee, we'll go ahead and pass it over to you. And then again, at the end, we can open it up kind of for a Q&A that could address either presentation as well, if anybody comes up with something later on they wanted to ask.
Okay, cool. Great job, Vitaly. Okay, I will try to follow that up with something as high quality. So I am going to talk a little bit more about the checksum database and some of the security considerations that the Golang founders have put into Go modules, as well as some of the stuff we're working on at GoCenter, which basically Vitaly is kicking butt on. So I'll go ahead and get started. I have the same slide, so if you guys haven't had a chance to go to the link, check it out. You can get the t-shirt, or you can also get the slides that we're presenting today. And I'll leave this up at the end as well. Okay, the agenda for my talk is we're going to start with a little introduction of who I am and what I do. Then we're going to talk briefly about the history of dependency management in Go, especially Go modules 113. I'm going to do a brief deep dive into checksum database concepts and what it means when you're committing a new module to that checksum database. Then near the end, I will do kind of a demo of the vulnerability information that we're providing in GoCenter, as well as the same information that we've just extended to our VS Code extension. And at the end, any questions you guys have, I'd be happy to answer. So as I said, I'm Deep Data. I'm the community product manager. So the community team, Mitali included, we get to work on all the really cool free stuff at JFrog. And we're here obviously giving a talk about our Go-related community product, which is GoCenter. So I'll talk more about what GoCenter is, but just so you know, like I am quite active on Twitter, and I would love if you have any questions or follow-up or just want to have a general chit chat, please email me, deepd@jfrog.com, or you can tweet at me. All right, so let's get into the talk. So you probably know that Go's gone through a few different concepts in dependency management. There was a concept called glide. Then there were some specific ways to, place your Go path to resolve your packages. And then Go experimented with the dependency management concept called dep. And finally worked through some issues with the vendoring, and now with one of them, they introduced the concept of Go modules. And Go modules, as Mitali said, are basically just a collection of packages. And with Go 113, modules became the official standard. So the way modules work, you, as Go developers, you know this, but the Go mod file defines the module path, which is also the import path used for the root directory. And with Go modules, Go introduced some security considerations that I think are pretty cool. So what I really like about Go 113 is how easily your Go mod file and then the Go sum file are created. Once I build my app, these are basically auto-generated for me. And it makes it quite easy for my modules to sync up to the checksum database. So the Go sum file is basically where your hashes live. And these hashes are used as a checksum. So basically a checksum is a way to provide authentication that a block of digital data hasn't been tampered with, or that it didn't break some of the data in transmission or in storage. So checksums are used to just verify the data integrity. But something to keep in mind is that they're not relied on to verify the data, the actual data security. So checksums, they can make sure that the data that was originally committed is the same data that's retrieved later. But it's not like checksums are doing any kind of like linting or real authentication. So with Go, this basically makes sure that your files that you're importing in your Go mod in your project are the same files that the author originally committed. So we're going to do a little deep dive into how this works with Golang's checksum database. So one of the concepts I want to dive into briefly is the actual hashes. So Go uses the SHA-256 base 64 hash. SHA just stands for Secure Hashing Algorithm, and it's probably the type of hash that's most commonly used today. Basically, SHA-1 was broken in like a research study, and so now companies are using SHA-2, which has never been broken so far as we know. And the way SHA works is generally you put a piece of data through the hashing algorithm, and through a bunch of fancy math, it spits out a 43 character string. And that 43 character string, that's the hash that's used to verify the integrity of the data later on. So what's cool is that a single character difference or a single character change in the original input can produce a dramatically different hash in the output. So if I even change one letter in the original file, the hash that comes out on the other end can look completely different. And this makes it very difficult to like reverse engineer a hash. You can't put it back through the hashing algorithm and reverse it and get the contents of the original file. And it also means that every single piece of data is completely unique, which you'll see why that's important to Go as I go along. So the way the checksum database uses these hashes is, at its core, the checksum database uses a Merkle tree structure, which is also something used in blockchain. So the data or list of hashes, it's actually stored in this block at the bottom, and then the data is actually put through the hashing algorithm and spits out a hash, and those hashes are then put through the same hashing algorithm, SHA-256, and spit out another hash all the way up to the tree. And basically the hash that results at the top of the tree is called the root node. And this makes sure that what this really does is it makes sure that the data that goes in at the bottom through this hashing algorithm, if there's any piece of data that is changed later on, it's very easy to understand where that data was changed, because the hash will change all the way up that branch of the tree. So Go basically uses this Merkle tree structure instead of like a normal database to show to show trust, to show that this data is basically tamper-proof, because if it's been tampered, you'll see all the list of hashes have changed. And basically, once you record some data in the log, it can never be modified or deleted. It's immutable. And we're going to get more into the way that Go modules work with the checksum database now. So if I have two apps, or two modules, my module 1, my module 2, they each have a GoSum file, and each GoSum file has a list of the SHA-2 hashes that I just mentioned. And the first time that I basically build and commit this, that GoSum file is committed to Google's GoSum database, GoSumDB, which is where those checksums are basically stored. And they're used to verify the data is intact. So the database is sum.golang.org. And so just in summary of what I just said, the checksum ensures that the Go command always adds the same lines to everyone's GoSum file. So this ensures that everyone is using the exact same code for any given specific version of that module. All right, so the way the hashes actually protect you is if I have module 1 and someone comes along and clones my module, and they change anything in module 1 and they save it as the same module version and they try to commit it to the checksum database, you'll actually get a checksum mismatch, because the hashes will no longer line up, right? So I've changed the data in module 1 and the GoSum file has a different list of hashes. So now the checksum database is going to say that's not the same module 1 that was committed earlier. This is really useful for security, of course, because it ensures the developer can't inject like new vulnerabilities into the same module version. All right. So the way this works kind of in the real world is, let's say you create your first Go module, and I import a bunch of dependencies, and I save my module, and I get the Go mod and the GoSum auto-generated. What I realize is, after I've already sort of committed this, that there is a sort of a low-level vulnerability in my code. So the text/template package that I've imported actually opens up my app to a cross-site scripting issue, which basically is when I send data through the browser, it's not encrypted. So anybody can use that data for nefarious means. So now, but I've already saved this mod and I've already committed it to the checksum database. So what do? I can come back to my module 1 and I can import the right dependency, which is the HTML/template package, which does include encryption. And what this does is it actually changes the list of hashes. And so what I have to do to commit this back to the checksum database is I have to version this this new file, this new version of my module. Normally, if you're making a small change, you would probably just save it as a patched version. But if you're making major changes, then of course you would release a version 2. And when you are versioning your modules, as Mitali talked about, you have to use semantic import versioning. So as you can see, if you're doing a patch version, you can basically update the decimal places to the right of the v1, and that can be updated in the path that you see right here with libfoo. But notice that if I release a v2, then the syntax changes slightly, and now I have a slash after the module name, and then v2, and the actual version numbers. So versioning is actually really important. Go is pretty strict on this, and this is one of the issues we run into a lot on the Go team, on the GoCenter team. So just make sure that when you're releasing new versions, you're following the right semantics. Okay, so now I've got my mod 1 and I have my mod 1 v2, and both versions have been committed to the checksum. Both versions have a different list of SHA-256 hashes. And so now they can both be authenticated correctly because they're versioned correctly. So what happens is that sometimes you may release a module update and the community doesn't know about it, right? So if I have my mod 1 and it's still out there, people are going to import mod 1 and vulnerability that I introduced. Basically, the developers that are using my app have that cross-site scripting issue. So what do I do to let the community know that there's a new version? And how do I basically let the community know that my mod 1, I guess, original version has vulnerabilities? So that's actually why we started building more security and vulnerability information into GoCenter. So to summarize really quick, the GoSum file uses the list of SHA-256 hashes to match the checksum when imported. The Go mod file stores your list of dependencies and the versions, and the hashes are used basically to detect misbehavior or breaks in your data integrity. But as I mentioned, vulnerabilities that were introduced in the original project and the original commit, they will basically remain in that specific version of the module. So if somebody imports it later, they still might, they're still gonna get that vulnerability. And that is gonna take me to GoCenter. So Mitali mentioned GoCenter is our GoProxy. It has over 700,000 Go module versions and counting, and I'll show it to you in about a second. And GoCenter is basically a place where you can get any publicly available Go module and any available version of those Go modules. You can also include your modules in GoCenter by using the add module or the inclusion process. And we take a lot of pride on the community team on our immutability factor. So all the modules in GoCenter are immutable. That means if the original source goes down, you can still get the module from GoCenter. Cool. So I'm gonna reshare. I'm gonna stop, and then I'm gonna reshare my screen so you can see see my host screen. All right, and I'm going to show you how GoCenter works, including the security concepts that we've introduced. So you can go to gocenter.io, and this is basically our landing page. So here in the search bar, you can go ahead and search for any module name. You'll see the module, a brief description. You'll see the module version, including any pseudo versions, the number of downloads, and the number of stars. So I'm going to go straight to a module that I know has some security issues. Here on this module page, we have a lot of metadata like stars, license information. You can flip through this. We provide the Go mod file contents. We provide a list of all the dependencies for every module, and it's version specific, which is cool. And we also have some metrics. But what I really want to get to is our new security tab, which we introduced in January of this year. So for every Go module on GoCenter, we have a list of any vulnerabilities. These are publicly reported vulnerabilities in a database or a list called CVE, which stands for the Common Vulnerabilities and Exposures List. And we basically use the JFrog Premium X-ray tool to scan all your Go modules, and then we're providing it for free in the UI. So you get to see the CVE ID, you get to see the severity level of the issue, and you get to see the description. And of course, if you want to know how to like remediate these issues, you can go get a trial of X-ray, and X-ray gives you a lot more info. But this vulnerability information has been really useful in terms of being more transparent about what's happening with your Go modules. And in fact, even the dependency tab has these little indicators that will show you the vulnerabilities that are in other packages or other modules that are being used as a dependency. And what's really cool is there's a versions tab that will show you what versions of this specific module have the vulnerabilities and which ones are vulnerability free. So obviously this is super, super helpful. The way that I basically have used this is I've started, we basically extended this capability to VS Code, and I've started learning a little bit more about how to build Go web apps. So I'll give you a super quick demo. I went online and I basically followed some tutorials, and I built this little grocery list Go app where my parents can they can add items for me to go get groceries. So maybe my mom wants to order some pasta. She can let me know what kind, right? Spaghetti. I'm gonna embarrass myself because I don't know how to spell spaghetti. So it gets added to my list. And the next thing I wanted to do with this web app is I wanted to actually not just commit this data to right now it's being committed to a text file. I wanted to commit it to a database. So I went and found a Go ORM module called GORM. And I basically opened that up. I'm going to open that up in VS Code. Oh, I got to move this screen. So in VS Code, I started building out the back end of that grocery list application using an ORM. And in my GoMod file for this application, oh, I pulled up the wrong one. This is the front end. Here we go. In my GoMod file for my GORM side application, what I have here is I've got GORM version 1.9.9. So with the new VS Code capability that GoCenter is providing, if there's a vulnerability in your GoMod file, you're going to see this red underline right here. And if I click on it, I get this little pop-up, which is a light bulb. If I click on the light bulb, I can actually see all the issues in the dependency tree. So I open this up and it tells me that I have a high level issue in GORM and as well as an issue in one of the dependencies. And you can even hover over the red underline. It'll give you some details around the module and show you that it has a vulnerability. And the way that I got this extension is basically, it's a JFrog extension. So I went to the marketplace, looked for JFrog, and you'll see that the description says X-ray scanning of Go, NPM, and Pi. So if you downloaded this extension, the Go scanning is actually free now. So you can get that extension, you can use your Go modules, and you'll get this capability of seeing the vulnerabilities. So now I'm going to go back to my presentation. Okay. Right, and so the last thing I just wanted to show you here is, again, in that story I told you before, if I have different versions of my module 1, I can actually use GoCenter to look at the list of versions and find one that isn't vulnerable. And if you do want to understand more about the actual CVEs, I would invite you to go to the CVE list, the common vulnerabilities and exposures list. This is actually a screenshot of the cross-site scripting issues that I talked about before. So you can go ahead and check that out. And then lastly, if you do want to know a little bit more about the two projects the modules I briefly mentioned, you can go to this tutorial and you can get the GORM IO module right there. So that's basically my lightning talk. The last thing I should mention is we are having Swamp Up June 23rd to 24th in the US and June 30th to July 1st in EMEA. So as Ari had posted, you can get some free tickets if you go to that link. And that is it. So if you have any questions, let me know. I will stop sharing and I will look in the little chat box. Okay. I see one question about, does the VS Code extension require using the proxy to GoCenter? No, it does not. So you don't have to set GoCenter as your proxy. The VS Code extension will scan your modules even with the default proxy. Any other questions? Oh, that's an interesting one. Does GoCenter blacklist any versions of modules that have severe vulnerabilities? We are, I believe, so we are not failing modules because of vulnerability issues. There are other reasons that modules will fail to be included in GoCenter. Right now, GoCenter is not taking them on the security of a module, but that's an interesting idea. For us, we really just want to surface to you, we're like a third party. We want to surface to you that these vulnerabilities exist. Are there any type of certified modules that GoCenter will endorse? We are not yet endorsing a specific version of a module. One thing we have started doing is we are awarding some of the modules that have a high quality score, something called a Go badge. So we've developed a back-end algorithm to score modules that have a lot of quality metrics and quantitative metrics met. We're calling this the Go score. You can actually look at the Go score on our wiki page. And basically, if a module has like a license, it has active contributors, it has low or no vulnerabilities, or it has some of the popularity metrics like used by and downloads. We spit out this Go score, and every month we pick 25 modules that we think are worth celebrating, and we give them a Go badge. We'll tweet about them on our Twitter. So we're just starting to kind of do things like that, but right now we don't officially endorse any specific modules or versions.